Hello everyone, in this video we are going to talk about what we are going to talk about. I am going to talk about neuromorphic computing. What is it in one? Why? What are the main case of it? All this we, all this thing we are going to talk about in this video itself. Do you get it? What I want to say? How do you get it? What I want to say? There is a topic on your heading or a title as you can say that, as you can saw it on your top of it. Neuromorphic computing. Beside it, so can I use it beside it? No, below it. Below it would be quite accurate word for it. Below it there is a paragraph. Through that paragraph I'm going to study about it. All this we are going to do. I think there is a four page of this slide. First page is about neuromorphic computing. How does it work? Second is biological inspiration, key principle of its application, where we use it, hardware implementation, advantage, challenges, research and development, all this. And there are 10 question in the end. All this are the different type of thing, quite to be like that. You get it? Want to say? Okay, shall we move it? I think there's some lighting problem all over my head, that's why I'm can't able to. I need to fix it. First, I want to on the speaking English, then I want to focus more on materialistic thing. And otherwise, I will keep continuing with this 720p camera. Or this, what does it call? Mic? Or this say mic. What once I will master my speaking English, then I'm going to focus on my then I'm going to focus on my or more realistic thing. Until and then I keep moving with this setup, same setup and same things. Cause I don't care about the watch rate or all this stuff. I just care about my skill. Even there is one view, 0 view per day on my video. I even that don't care about that. I just care about myself. I just want to race with myself. Nobody, and I don't want to be like, oh, even if I get that much out of, even if I got that amount of subscriber, then I'm going to keep continuing. No, bro, I just love this. I just love doing this kind of thing. I'm keep doing until if I if not even then I will not got any subscriber in it. Even then I will keep going, keep hustling for that. Do you get it? What I want to say? Do you get it? What I want to say? I'm saying I'm keep going. Even then I'm not got any subscriber or any kind of boring, because I love doing this kind of thing. I can express my, why do I love doing this kind of thing? Because I can express my own word through this, and I want to improve on a skill. And if you are improving your skill, then that's the meaning of your life. Otherwise there's no meaning of life. If you have set, if you set a goal for your life, and you are here and want to achieve, you have to fill out this gap. And filling out this work while working daily on the same task is the all meaning of life. There is no other meaning of life. That's why I'm saying I will keep doing, doing, but I will make changes, not the same forward. Like if I got comfort in for particular in particular format or thing, then I'm going to change it. That's my whole holistic goal. It's like not like that I like reading an article or from an user that and got comfortable in, then I'm not going to change the format. No, bro, I'm just going to change it and try to come in a more other place areas in order to give more, surface area, or in order to give you more space for learning, not coming into a comfort zone, all that stuff. You get it? I want to say. Do you get it? What I want to say? Okay, let's move with the topic itself. Neuromorphic computing. Neuromorphic computing is a branch of computer science. Neuromorphic computing is a branch of computer science that engineering seeks that design of a computational system inspired by the architecture and principle of human brain and our system. This system are designed to make the way the brain process information using artificial neutral line neural network and hardware that can perform tasks like perception, learning, and decision making in the energy efficient and parallel fashion. Okay, we have read about the what does it mean? Neuromorphic computing is a branch of computer science. It's a branch of computer science and engineering that seek to design and build computational system inspired by the architecture and principle of human brain and nervous system. This system are designed to mimic the way brain process information using artificial neural network and hardware that can perform tasks like perception, learning, and decision making, and energy efficient and parallel vision. All that can be said about the neuromorphic computing. Now there are different terms are going to be used, like what are the biological inspiration, key principle application. All that we are going to study about that. Neuromorphic computing model. It's new artificial neural network after the neuron in its brain, human brain, which is fundamental information processing unit. Neuromorphic computing model. It models its artificial neural network that after the neuron in a human brain, which are the fundamental information processing unit. Synapse in a neuromorphic system are artificial synapses are used to connect neuron and enable communication between them, similar to the system in the brain. Key principle: parallel processing. Neuromorphic systems are highly parallel, which means they can perform many computations simultaneously, making them suitable for tasks like image and speak recognition. Energy efficiency. One of the primary goal of the neuromorphic computing is to achieve high energy efficiency, often while learning, by emulating the brain ability to perform complex tasks like minimal power consumption, learning the adaptation. Neuromorphic systems are designed to learn from the data and adopt their behavior, similar to how a brain can acquire new skill and knowledge. Is it possible? Hmm. Application: AI and machine learning. Neuromorphic AI and machine learning. Neuromorphic computing has application in artificial intelligence and machine learning, where it can be used for tasks like pattern recognition, neural language processing, and autonomous decision making. Sensor processing. Neuromorphic system can process data from sensors like camera, microphones, real time, enabling applications in robotics, autonomous vehicle, and Internet of Things. Neuromorphic vision. The system are particularly suited for neuromorphic vision, which involve processing visual data efficiently and quickly, as in self-driving car and surveillance. Do you get it? What I want to say? Hardware implementation. Neuromorphic chip. Specified hardware, often in the form of neuromorphic chip, is designed to accelerate neural network computation in brain-inspired manner. Example include IBM True North or Intel Loy. Memorators. Memristors. I just know to know about it for first time. I'm reading this word for first time. That's why I'm got quite confused about it. What does it mean? My memristors. Some neuromorphic system are memristors, a type of electronic component to mimic the behavior of synapses in biological system. Advantage: energy efficiency. Neuromorphic computing can perform complex tasks with low power consumption, making it suitable for battery powered devices and environmentally friendly computing. Real time processing. This system excel to real time processing of sensory data, which is crucial in application like autonomous vehicle. Cognitive computing. Neuromorphic system have a potential to create machines with cognitive capabilities such as reasoning and problem solving. Challenges: scaling up neuromorphic system to match the complexity of a human will remain a significant challenge. Programming model. Developing efficient programming model for neuromorphic design hardware can be challenging, as they differ from traditional von Neumann architectures. Ethical and privacy concern. As neuromorphic computing advances, there is ethical concern related to privacy and potential to misuse, especially in the surveillance and data analysis. Research and development. Neuromorphic computing is active area of research and involving collaboration between computer scientists, neuroscientists, and engineering to unlock its potential. Its full potential. You got it. We have discussed various aspects of the neuromorphic. Like there is where art are the biology component inspiration neuro is transferred to the computing model artificial after neuron humor in which fundamental information processing unit. Like it used in the field of, like, we can read about the neural link developed by the one of the most famous person, Elon Musk. Not developed by the, founded by the, founded by the him, and they are doing quite big progress. Yesterday itself there is a news that they are going to implement a chip in human in coming days, which can be help a person, which they are going to implement to work properly. Like those person who can't walk or can't work, this is going to help out them. They are saying that synapses is in neuromorphic system, artificial synapses you need to connect neuron and enable communication between them, similar to the synapses in the brain. Key principle: parallel processing, energy efficiency, learning and adaptation. Application: it can be used on the AI and machine learning, sensor processing, neuromorphic vision. All these are the application of it. Now hardware implementation. How does it work? A neuromorphic chip we can use in the field of neuromorphic chip. Memory stores. I got to confuse about that. What does it mean by? It's a system of a type of electronic component. We can say the electronic component to make the behavior of the synthesis of biological system. Advantage: energy efficiency. Neuromorphic computing can perform complex tasks with lower power consumption, making it suitable for battery powered devices and environmental friendly computing. Real-time processing. This system excel at real-time processing for sensory data, which is crucial for application like autonomous vehicle. Cognitive computing. Neuromorphic system has a potential to create a machine with cognitive capabilities such as reasoning and problem solving. Scalability. Scaling up neuromorphic system to match the complexity of human brain remains a significant challenges. Programming models. All this we have discussed. Ethical and privacy. Okay, now we have to the last slide of this presentation, or can last page of this slide can be used, where we have to discuss various questions related to this. So what is the first question? First question is related to the primary motivation behind developing neuromorphic computation system is to create computational system that mimic the energy efficiency and parallel processing capabilities in human brain, enabling tasks like real-time sensory data processing and learning. It can be that form. How does artificial neuron in neuromorphic computing differ from traditional digital computing? Like artificial neural in neuromorphic computing differ from the traditional digital computing like CPUs and GPU. Artificial neural in neuromorphic computer are designed to perform analog computation, like while GPU primarily perform digital computation. What is the difference between analog computation and digital? This allow neuromorphic system to process and form more like a brain. Analog computation, does they can't use electronic charges or induction there? I don't know what does it mean by. What are the advantages of neuromorphic computing for real-time sensor data processing such as autonomous vehicle or robotics? Neuromorphic computing excel at processing sensory data in real time due to the parallelism or and energy efficiency, making it suitable for applications that require quick decision making based on sensor data. Can you explain how learning, adaptation, and working in neuromorphic computation, what type of task they cannot do? Neuromorphic system can sympathetic plastic and adjust the strength of the connection between artificial neuron, then can adopt a task like pattern recognition, speech processing, autonomous navigation while learning from data. What challenges do research face when scaling of neuromorphic computation to match the complexity of human brain? Scaling of neuromorphic system require addressing issue related to power consumption, connectivity, maintaining the brain of level of parallelism where significant challenge in challenge. Are there practical application of neuromorphic computing in healthcare industry and or in medical research? Yes, neuromorphic computation can be used in task medical image analysis, disease diagnosis, or drug discovery. It can be able to process complex data pattern efficiency. How does the development of neuromorphic hardware like neuromorphic chip contribute to advancement of artificial intelligence and machine learning? Neuromorphic hardware accelerate neural network computation enabling faster and more energy efficiency training and interference of AI machine learning technology. What are ethical concern are associated with the use of neuromorphic computation, particularly in the application involving surveillance or data analysis. Ethical concerns include privacy issues related to surveillance, data security, potential of misuse of neuromorphic technology, emphasizing the need for a responsible development of regulation. Can you explain the memory stores? This word is not living. Memory study used in a neuromorphic system a role of mimicking biological synthesis. Membristors are electronic components that change resistance in a response to electric signal. A neuromorphic system that emulate behavior of synapses while adjusting their resistance based on the strength and connection between artificial neuron. What is the role of interdisciplinary collaboration play in a field of neuromorphic computing and why it is essential? Interdisciplinary collaboration involving computing neuroscientists, engineering is vital. Vital gap between neuroscience and technology, enabling the development of more biological, inspired, and capable neuromorphic system. I think that's it for the video. We'll see you next time. Already 15 minutes has passed in it.